Hello everyone. So today we'll be discussing one problem regarding logistic regression. Okay, so this is given in the week 3 of the NPTEL course Introduction to Machine Learning in the week 3 quiz. So this is more of calculations using logarithm and exponentiation. So here this is the problem. Okay, so consider a modified logistic regression. Okay, here you can see consider a modified logistic regression given below, where k is a positive constant and beta naught and beta 1 are parameters. Okay, so here in this question a little typo is there. This equal symbol should not be there. Okay, so it is basically log of 1 minus 1 minus p of x. So this p of x generally signify the probability of x. Okay, k is that constant multiplied by p of x, which is equal to beta naught plus beta 1 x. Correct? So here I need to find actually this p of x value. Okay, if I from this particular expression that is given, which they are saying that it is a modified logistic regression, I need to like from this expression I need to find what is the value of p of x. Okay, so if we further do some calculation here, if I apply the exponentiation, okay, like logarithmic here, if you remember, if we write like this particular e to the power log of x equal to x. Okay, this we have to remember. So that's why I will try to apply exponentiation on both sides. So it will become like e to the power this entire log term, okay, whatever is there, equal to e to the power beta naught plus beta 1 x. Okay, and this will give me further simplification, whatever is there in the power term, that logarithm of that particular value, if it is x. Okay, if it is x, then final output is x, right? So that's why here it will be 1 minus p of x. This was inside that logarithmic term, right? Multiplied divided by k p of x, which is equal to again e to the power b naught plus b1 x. Further we can do more simplification, like suppose 1 minus p of x equal to, I can bring this down to the right hand side, k multiplied by p of x multiplied by e to the power b naught plus b1 x. Okay, which is equal to again 1 equal to p of x plus k multiplied by p of x multiplied by e to the power b naught plus b naught plus b1 x. Okay, which is further it is, if I now find the p of x value, 1 equal to, suppose p of x, if I take common, it will be 1 plus k multiplied by e to the power 1 plus e to the power b naught plus b1 x, correct, which is equal to p of x will be equal to 1 divided by 1 plus k multiplied by e to the power beta naught plus beta 1 x, correct. So this term I am finding out this term, which is further equal to, if I need some expression. If you see the options, okay, so this is the actually answer, p of x. Let me just change the color here. This is the value of p of x, okay, but in the options the representations are different, right? So I need to have some e power term on the numerator, okay, so e power b1x, correct, something like that. So how I can improve it further? By dividing p of x equal to, on both the numerator and denominator, here you see on the denominator term I have e to the power b naught plus b1 x, right? So here you can see almost all the terms are having e to the power b1, e to the power b1, e to the power b1, e to the power b1. With the k term they are only having here the k term is also not there, they are only having e to the power b naught, okay. So what I will be doing with the k term, I need e to the power b naught, okay, and with the rest of the term I need e to the power b1. So what I will be doing, I will be dividing both the numerator with e to the power b1x and the denominator as well as 1 by e to the power b1x plus k term is there, and if I divide e to the power b naught, this you can further write as e to the power b naught multiplied by b1x, right, and I am dividing it by e to the power b1x, correct. So which is equal to here this term e to the power b1x and e to the power b1x, this I can cancel out, right, and I can write the numerator term e to the power b1x, but because it was in the denominator, if I write like this, then that is the same term, right. Similarly e to the power minus b1x plus k multiplied by e to the power here it will be only b naught, right. It will be e to the power b naught. I hope it will be e to the power b naught, correct. So this will cancel out. If I now again verify with my options, you see the first option e to the power b1x, okay, b1x in the denominator, e to the power in the denominator also it is e to the power b1, okay, with the k term I am having e to the power b naught. So this is one, with the k term I am having e to the power b naught, but in the numerator and the denominator I am having negative symbol, right, e to the power minus b1. So the fourth option, that's why is correct, which is similar to this derived answer just now that I have got, okay. I hope you understood. Okay, thank you.